Hi everyone, and welcome to a series of interviews for Open Conference. My name is Matina Tsavli, and I am in the organizing committee of Open Conference. Today, I have the pleasure to have with me Ioannis Kolaxis, software architect and technology research principal director at Accenture. Hi, Ioannis, and welcome.
Hi, Matina. Thank you for the invitation. It's my pleasure being here.
It's great. So, I jump right to the questions. Your work primarily focuses on green software innovations. Could you explain what green software is and why it's important in today's technology landscape?
Yeah, sure. Green software is the set of practices that we apply as software engineers to reduce the carbon emissions coming from software. A lot of times I hear the question, so how is software related to carbon emissions? It's not always clear what the relationship is. As we all know, software runs on servers, on data centers, and all these data centers, all these servers consume a lot of electricity. To generate electricity, we usually burn fossil fuels like coal, gas, diesel, and by burning all these fossil fuels to generate electricity, that's how a lot of carbon is emitted into the atmosphere. So our software consumes all these resources, and the more resources our software consumes, so the more servers we need to run our software applications, the more CPU, RAM, the more network traffic we create, we consume more electricity. So going back to software development, so green software engineering is about rethinking how we design and how we operate software to do this in a manner where we reduce the energy our software consumes and sometimes consuming the energy in a clever way so that we consume cleaner energy. So, for example, if we have compute intensive applications, we run them only when the sun shines and the wind blows. That's the time when we have clean energy of low carbon intensity. Whereas if we run our software late at night, it's likely consuming electricity coming from burning coal or other fossil fuels. So that's green software engineering in a nutshell.
Does it depend also on the kind of software written? Would it make any change if the software was different?
So there is a study, there is an academic study that different languages consume different energy. So, for example, compiled languages like C and C++ consume less energy than interpreted languages like Ruby, Python, and Perl, which can consume up to 70 times more energy than compiled languages. So somehow there is a relationship between the programming languages that we choose to write our programs and the energy consumption.
Okay, that's very, very interesting. So, you've authored a book on Greek software. What motivated you to write the book, and what key insights or takeaways can readers expect to gain from it?
Yes, so green software engineering is an emerging field, and there is a lack of information of what practices we need to apply to, first of all, to measure the impact of our software. There is a saying that if you do not measure, if you can't measure, then you can't improve. So the first important aspect is how do we measure the carbon emissions? And then the second aspect is what practices can we apply to reduce our carbon emissions? So there was a big gap in that area. And as I am working as a software architect, one of my main tasks was to reduce the complexity of software solutions and reduce the operating costs to make the products more competitive. So by looking this from a different perspective, what I was trying to do, so reduce the complexity and reduce the costs, led to reducing the resources that these applications consume. So I found out that I was already working on that field. I was already applying green software engineering practices, and I thought of sharing them with the development community, aspiring to empower software developers to apply these practices and make an impact in reducing the environmental footprint of our software applications. So that's how I started writing that book.
And apart from a book author, I know you are also a patent author. You filed more than 5 patents on software solutions related to remote work and emergency services. Could you elaborate on one of these innovations?
Yeah, sure. So one of these is related to emergency services. So if you're walking on the street and you see a building on fire, that's a hypothetical scenario. So you see a building on fire, then we know that you have to pick up the phone, you have to pick up your mobile phone and call 911 or 112, the emergency services. And then someone will pick it up and you have to explain what is your location, what is the type of emergency, are there any humans in danger, or is it just the building that is burning? And it can take 1 to 1.5 minutes to provide all these informations. And in these situations, time is critical. Emergency services must dispatch the fire trucks as soon as possible. And if it is a large scale incident that a lot of people are calling, then you are likely going to wait in the phone line, in the phone queue until someone picks it up and you explain to them what is going on. So that's the main challenge. And the solution I provided there is that, we all have smartphones nowadays. So why should you just call and explain what is going on? Instead, you can just take a photo of the incident and send it to the emergency services. And on the other side, you don't need to have a human to look at the photo and interpret this. You can have artificial intelligence, a software that inspects the photo, and depending on if the photo is an emergency or not, and depending on the type of the emergency, the software will automatically dispatch the services that are required. So do you need just a fire truck, or do you also need an ambulance?
Okay.
Or for the case, let's say, of car accidents, is it a light car accident or a severe car accident? Depending on the type of the accident, you may or may not send a fire truck or the ambulance. So that's the idea. And uh, the key here is that it attempts to reduce the so-called response time, the time it takes for emergency services to arrive on site.
That's great. That's very innovative. And also I
Yeah.
guess from the metadata of the picture, they can get the exact location of the building.
Yes, exactly. So whenever we take a photo using a smartphone, the location is embedded inside the photo. So on the other side, when you receive the photo, this is contained, the location is contained is inside the photo as metadata.
Okay, that's a great achievement. And you will be talking in our open conference about green tech. So could you please give us a short teaser about what we're going to talk about?
The main topic of my presentation is about rethinking, reinventing how we develop software. Software runs on every kind of device around us. It's not only the servers running on data centers, but it's also all these personal devices that we have, from laptops to smartphones and tablets. And this is where the biggest problem lies. We have billions of devices around the world, and we change them every 1 or 2 years. And so we need to rethink how we design software so that we prolong the life of these end user devices, first of all. Then we need to optimize our software applications that run on the servers, again, to reduce their energy needs, their energy consumption. And last but not least, we use networks, data transmission networks, to exchange data from our user devices to the servers. And these networks also consume significant amounts of energy. So it's about rethinking how we build software across the stack, from the end user devices to the data centers, and how these interact via the data networks to make our software greener.
Great, that sounds great. So thank you very much, Ioannis, for accepting our invitation to speak at Open Conference. Open Conference this year will be held at the University of West Attica on November 10th and 11th. You may find the link to book your tickets at the video description below. So thank you, everyone. Thank you, Ioannis, and see you at the
Thank you,
conference.
Martina. Looking forward to the conference.